Hi guys, welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at AQA Mathematics Statistics MS-SS1B May 2011 examination question number 6. Let's read the question. An amateur tennis club purchases tennis balls that have been used previously in professional tournaments. The probability that each ball fails a standard bounce test is 0.15. 0.15. The club purchases boxes each containing 10 of these tennis balls, assuming that 10 balls in any box represent a random sample. Then part A and part B, there are 3 parts in part A and 2 parts in part B. So totally 6 marks for part A, 5 marks for part B. Let's try to go through the question. The first part of part A is that we have a table here. Let's read about the table later, and let's read the question. Determine the probability that the number of balls in a box fail the bounce test is at most 2. So basically there is a probability distribution. X is binomially distributed with 10 number of balls because the sample size is 10 and the probability P is 0.15. So basically we have a condition where n is equal to 10. In this case n is equal to 10 and P is equal to 0.15. So therefore we go to table of cumulative binomial distribution with n equal to 10. Please go to the column where go to the row where n equal to 10, and then we need to find out the probability. In this case P equal to 0.15. 0.15 column is the one that we are going to look at. So the first part is to at most 2. That means probability of X. So less than or equal to 2. That means maximum 2 failures. It can be 0 failure, it can be 1 failure, it can be 2 failures. The probability of failure is 0.15. So basically what we need is the probability until, because there can be like P0, P1, P0, P1, P2, P3, P3, 0 failures, 1 failure, 2 failures, 3 failures, like that. There can be many failures, but at most 2 failures, that means up to 2 failures, what is the probability? So therefore what we need to do is to go to the value of X, which is equal to 2, and the probability. So first we chose that n equal to 10. Please note that we need to find the n equal to 10 table, because there are only 10 balls in this particular sample, and then go to the column where probability is 0.15 and then find the intersection. So you get the probability here 0.8202. that is the probability of at most. That means it can be 0 failure, 1 failure, or 2 failures. At most 2 failures. Okay, so that's the first part. And the second part, at least 2 failures. This is actually the other way around, the probability of at least 2 failures. So again, if you write the distribution underneath here, P0, P1, P2, P3, P4, like that. So at least 2 failures. That means we need to eliminate this part, but we have to take this part. That means 2, 3, 4. So 2 failure, 3 failure, and 4 failures. So that means we need to take away from, if you add all these, we get the probability of 1. That is, the total probability can be 1. So all the possible failures. So out of those total probabilities, we need to take away this one. That means we need to minus of probability x less than or equal to 1. Please note this condition, because we need to take 2 into consideration, but we are eliminating p0 and p1. So therefore, in the table, when you read the binomial distribution, cumulative binomial distribution table, we need to read for x equal to 1 condition. That is the area for p0 up to p1. So therefore, px greater than or equal to 2 is equal to 1 minus. So if you go to the table again, now it is 1 and probability is 0.15. So this is the number. Probability 0.5443. 5443 is equal to 0.4557 or equal to 0.456 for to up to 3 decimal points. Okay, so there are two different situations, at most 2 and at least 2. Okay, let's carry on to the next question, part 3 of part A. So let's see what is the question here. Determine the probability that the number of balls in a box which fail the bounce test is more than 1 but fewer than 5. More than 1 but fewer than 5. Again, I prefer you write the probability probabilities. That means P0, P1, P2, P3, P4, P5, P6, like that. There can be failures in different number of failures. So more than 1, so that means there should be more than 1. P1 should not be included. P2 up to P3, P4, P5, fewer than 5. So 5 should not be included. That means, so what they are interested in this area, P2, P3, P4 only. We need to get rid of P5 onwards or P1 downwards. That means our probability is equal to 1 less than, so 1 can be included x to 5. That is the more than 1 but fewer than 5. More than 1 is not included, fewer than 5 is not included. So when we read the probability, cumulative probability distribution, what we need to read is that P probability x less than or equal to 4, because we need to get the area from here. That means less than or equal to 4 minus probability of area from here, P1, not P2, P1. So basically probability of x less than or equal to 1. So please note that this is a discrete probability distribution. So therefore, if you want to avoid P2 being taken in, we have to start from P1. So the boundary is at P1, P2, but P2 we need to consider from P1 the area. So that means area from P1 will be removed up to 0 and area from P4 will be taken in. So basically P4 up, down, and P0, P1 down, then you finally end up with P2, P3, P4. So please note those two conditions, and then it's easy. Just go to the table again, n equal to 10 table. Please note that, and then this is the cumulative binomial distribution table, and the probability is 0.15 is given. That is the failure probability, and the n equal to 4 condition is in this row, and when it intersect with this 0.015, you get this probability here. That means 0.9901 minus, and then go to this one, x equal to 1 in this case, and again same probability here, 0.5443, 0.5443. So when you simplify, we get 0.4458, or which is equal to 0.446 to 3 decimal points. That is the condition for more than 1 but fewer than 5 balls to fail. Good. Now question number 6, part B. Let's see the question. Determine the probability that in 5 boxes the total number of balls which fail the bounce test is more than 5. So now we have a different condition, because now our n is equal to 10 in one box. There are 5 boxes, 50. N become 50. The probability of failure still 0.15. So therefore please note that we need to take the table 1 and go to the area where n equal 50, that is the cumulative binomial distribution function, n equal 50, but still the probability is 0.15. So we are looking at this column. So what we get here is a probability distribution, binomial distribution with n equal to 50, and the probability is 1.15. In this case, what we look at is that more than 5. That means the probability of y greater than 5. So again, if I look at the simple way of understanding this one, P1 failures, P2 failures, P3 failures, P4 failures, P5 failures, P6 failures. So what it says that there should be more than 5 failures. That means there should be more than 5. So that means these are the probability that we need to consider. More than 5. 5 should not be included. More than 5. So that means when you take the area under the curve, we need to consider from here. That means we write equation, because total area is equal to 1 under the probability distribution curve. Since it is more than 5 failures, 5, 6, probability of 6, 7 are all more than 5. So the area under the curve that we consider is total area minus from 5. That means 1 minus probability of y less than or equal to 5. Again, because of the discrete nature of the probability distribution, we need to take the, if you want to keep P6, we need to take from P5. So it will be from 5. So therefore, again, if you look at the probability table, we go to 5 here, and then intersection between 1.15 and 5 is somewhere here, this number here. So therefore the probability y greater than 5 is equal to 1 minus 0.2194, which is equal to 0.7806 or 0.781, which is to 3 decimal points. Great. That is the answer to part A, part B, question 6, part B, part 1. Let's see the last part of this question, question number 6, part B. Determine the probability that in 5 boxes the total number of balls which fail the bounce test is at least 5 but at most 10. Again, our distribution, cumulative distribution, same, table 1, cumulative binomial distribution, and the value of n is x equal to, because y is a distribution, binomial distribution with n equal to 50, probability is equal to 0.15. So this is our function, probability distribution. Okay, if I write the basics here, P1, P2, P3, P4, P5, P6, P9, P10. So what we are going to look at is the at least 5 but at most 10. So 5 failures, at least 5 but at most 10, maximum 10. So we are looking at a region, in this region, at least 5 failures, at most maximum 10 failures. So that means P11 is the next one there. So what we actually look at is an area. So we start from this and take away up to here. So that means our reduction area that we need to reduce is Px, y is equal to y equal to 10 to y equal to 4, we have to take away. That means if I write the equation, probability of 5, y should be in between 5 and 10. So that is the given condition, at least 5, at most 10. So our the area that we should look at is probability of y less than or equal to 10 minus probability of y less than or equal to 4. Please look at here, it's not 5, it's 4, less than or equal to 4. So if you take 5, even though this looks like you need to take 5, but 5 should be included. That means you need to take the boundary here and take values below 5, that means 4. So it's simple. Now once you have this one, it's basically what you need to do, go to n x equal to 10 and read the column under 0.15. So you get the probability for that particular event 0, that area is 8801. That is the area from P10 up to P0. Actually P0 should be there also, P0, P1, P2. So it is the total area up to P10 is 0.8801 minus the area up to P4. That means go to x equal to 4, find the area which is equal to 0.1121. So that gives us the answer to be equal to 0.768 up to 3 decimal points, basically exactly 0.768. That's all. That's the answer to the AQA AS Statistics MS-SS1B June 2011 examination, question number 6. In fact, this was held in May, but sometimes we call it June, so it may be a May-June examination, but we always refer to as a June 2011 examination paper. Okay, thank you.